guys, welcome to 5mantra.com. This is Kalyan, the Faculty of Aptitude, and today we are going to discuss about the beautiful concept of mensuration. Now let us see one more different application from the mensuration, and this is also one of the different analysis that we have to do. Okay, let us see what it is. See, here length of the rope required to tie the three cylindrical pipes tightly having the equal base radius, okay, and each radius would be capital R. That is our question, okay, and we need to, what we have to do here, just see. I think you can observe the image, okay, you can observe the image here like this, they are tied, okay. Then we are asked to find out okay, this length of this rope, which is on another side of the pipes also, which is not visible in this in this diagram, okay. So let me show this, guys. Let me show, I mean practically I want to show this, show one example for this, okay, then it will be clear. So guys, here let us observe for the problem, just I want to show you practically that how the pipes are tied here. Just see this pipes, okay, you can observe this pipe. See, this is a thread, it's a thread, okay, this is tied along this curved surfaces, okay, along the curved surfaces, okay. Now it is tied and we need to find out length of this, and moreover I want to give you one more observation in this, that would be here this tied rope is in the shape of circle or some other shape. See, so many misconceptions are there about this problem, that they may think that this is also one more circle. I mean this this rope which is tied is also in the shape of circle. That is a misconception. Is it a circle? Okay, is it a circle? It's not a circle, no. Here just see, this is a rope tied. Is it right or not? Is this a rope tied or not? This is a rope tied. So can we say that the rope which is tied is in the shape of circle? It's not a circle, no. Is it a circle? No. Someone says that it's a triangle. Is it a triangle? No, because here this is straight, okay, and it is some curved, and again this is straight, and this is again curved, and this is again straight, and here again curved. That means this shape is not even circle, I mean neither circle nor triangle. I think you guys would have understood this. I want to show you this practically only to say that, see, so many students says that this, I mean this rope which is tied is in the shape of circle. Is it a circle? See here, is it a circle? No. Why? Because here this is curved, but here it is straight or not. When it is tightly tied, okay, when it is tightly tied, here at this edges it is very straight, and here it is curved, and again here it is straight, okay, here it is straight, and here it is again straight, and here it is curved. That means here it is, I mean this shape is not describing a circle, I mean neither circle nor triangle. Someone says because it is straight, it's a triangle. So I want to explain you, and I want to make you know that here only thing that here this is never be it never be circle or triangle. It's not none of the shapes which you assume, okay. Once again I am telling you guys, this shape is not a circle and not triangle also. So here anyways, what is our target? Here we need to find out the length of this rope which is tied, and second thing is here this is this shape of this rope tied is not in the shape of circle. That's clear. So here let us observe this, guys. Once again I am showing you in different directions, okay. You can observe that it's not a circle, it is somewhere it is straightened and somewhere it is curved. Okay, here it is straightened, here it is curved, here it is curved, and here it is straightened. That means it's not a circle. Please try to imagine for this kind of this type of topics, more than intelligence, your imagination takes much role. See this, guys, once again I am showing you in close shot. Okay, this is a shape, this is a shape, this is the shape. Okay, just see, it's not a circle now. This is straightened and this is curvilinear, and this is again straightened and this is again curvilinear. So it's neither circle nor triangle, neither circle nor triangle. Is it clear for you or not? Nice. Let us go on to the problem. So guys, you might have observed that how the pipes are tied and what is the shape of the rope which is tied around them along their curved surfaces. Now let us draw the front section diagram of that and let us observe that. So the three pipes are like this or not? Okay, now so this is the front section, means basis of the cylindrical pipes in the front view. Okay, now in this front view, now the rope will be tied in a shape of what? Just see. Now rope is in this shape or not? Rope is in this shape. Okay, so now we got the shape of our required shape which we have seen in the practical image. Okay, this is the shape of rope or not? Once again telling you that this, here it is straight, here it is straight, and here it is straight, but here it is just curve. That means it is not triangle and not circle. Okay, it's some another shape. Let us suppose I'll show you here that like if you want to draw this separately, it is somehow like this shape or not? According to geometry, for this there is no existence. Okay, now according to geometry, here this straightened and these three edges are straightened, but here these are curved. There is no such a shape existing in the geometry. Actually that is the true, but anyways we have to find out the total length. So in order to find out the total length, if you want to do the problem directly, it's quite impossible. At that time, again what I said you and the previous problems, like we have to do the analysis for the figure. That means we can't do the problem as given it is, as given. Then how to do that problem? We have to do this by separating, means making the partitions of the diagram. How to partition them? Let us draw one thing. Let us see, let us plot the centers of the circles. Somewhere like this or not? That's it. Now go for plotting the go for joining the lines. This would be radius and again this would be radius. Both are joined together. I think we have joined like this in previous diagrams also in different cases. Now again if you join this centers also, again we can join these two centers. Now we have joined all the centers of the circles in the basis of the cylinders. Here we have joined. Now let us join, let us do some more construction. I am joining these centers with the point on the circumferences like this, means I am plotting this. Okay, as we cannot find the total length of this rope around it, we divided this into different partitions. Now let us analyze each and every partition. See here, for example, now just observe, is this a radius or not? Means this part, and this part is again a radius or not? Again a radius. And these all are radii. Okay, these all are radii of this, right? After getting the radius, now we have to observe something that, see, this tied rope is, see, I'm plotting this rope again here. Observe this. Okay, if this is in the shape of circle, then rope is this one or not? Then is rope acting as a tangent to that or not? Okay, tangent to this circle or not? Yes. So here tangent at the point of contact, we can join the radius or not? Okay, we can join the radius at the point of contact of the circle to the tangent. Here it will join or not? Now to this tangent it will be perpendicular according to the geometric rules, and technically this line is known as, this radius is known as normal. Okay, whatever, we don't bother about those all. So anyways, so here I just want to say you that understand this problem first, understand the problem, and then we can do anything. Okay, now so when this is 90, then this is 90 degrees or not? This is also 90 degrees. So when it's a quadrilateral or not? Is this a quadrilateral or not? When it's a quadrilateral and two adjacent angles are 90 degrees, and here also it will make what? 90 degrees only. So what kind of diagram is formed inside? Just see this type of diagram or not? What do we call this? Is it a rectangle or not? Okay, in rectangle, so this is a rectangle, and this is a rectangle, and this is a rectangle, and all are rectangles obtained as three parts. Okay, let us write it down. In a rectangle, what about the property of the sides? Opposite sides are equal or not? So here this side will be equal to this side. So what can we say here? So what can we say here? Here this length would be, this length would be how much? This is 2r, means here also opposite side of the rectangle, this is opposite side of the rectangle, so this will be also 2r. So this is again 2r. Similarly, all of them are 2r's or not? So these all are 2r's. So guys, here what did we find? Here this length of the rope is can be find like 2r, and this length of the rope is also 2r, and this length of the rope is 2r. Once again telling you, this is a total rope. This is a total rope. Okay, in that total rope, we divided into different portions. Now we find this length of the rope, and this length of the rope, and this length of the rope. So what is the total length obtained over there? Here one 2r, and here another 2r, and here another 2r. So how many 2r's are there? 3 2r's, that is 6r. But still total length of the rope we couldn't obtain, because there are still more segments are still left. So here this is one more segment we have to find, and this is one more segment we need to find, and this is one more segment we need to find. Getting my point or not? Here we find the length of this, and we find the length of this. What do we call this? Is this an arc of circle or not? Is this an arc of a circle or not? So like this is one arc, and this is one arc, and this is one arc. So 3 arcs, and here 3 2r's. Understood? So this 2r, this 2r, this 2r, this arc, and this arc, all should be added together to get the total length of the rope. That is our question. So now we have got here this 2r's, but what about the length of the arc? Arc means this curved part. See, that is length of arc. To find out the length of arc from the mensuration of basics, what are the measurements required? Angle made by the arc in the sector. See, is this in the form of sector or not? I'll show you. Just see this, guys. I'll show you here beside the diagram. Okay, I'll show you. See, each one, is this a sector or not? I'll show you separately. Is this a sector or not? Now, in this we need to find out this length. This length is called arc or not? Arc. How to find out the arc? Theta by 360 into 2 pi r. Theta means what? Angle subtended. And r means what? Radius of the sector. Means here we took capital R. We got that or not? So here capital R is a radius, but we don't know the angle made at the center. Means we need to find out this angle. In order to find out that angle, I am doing small analysis for this for you. It's a very simple one, but you have to understand. See, is this a rectangle or not? So what is the angle made here? 90 degrees. And this also would be a rectangle, and angle here would be one more 90. And just see, observe this, guys. In the previous part also we have joined this triangle. These are three equal circles. So while joining the centers, okay, the equilateral triangle will be formed or not? Here also you can observe this is 2r, this is 2r, and this is 2r. So equilateral triangle is formed or not? So what is the each angle at the corners of equilateral triangle? 60 degrees or not? So just see. So this is again 60 degrees. So that is 60 degrees. Let us observe, guys. This total angle would be 360 or not? Out of this total angle 360, here 60 is occupied, and here 90, here 90. What is that? 90 plus 90 plus 60 is already occupied. How much is that? 180 plus 60, 240 or not? So out of total 360 angle, here this angle would be 240 degrees. So here this angle would be 360 minus 240 or not? 360 minus 240 would be how much? 120 or not? So here each angle of the sector, the same case happens. Okay, the same case is possible for all the sectors or not? So here also angle would be 120 degrees, and here also angle would be 120 degrees. So now let us find out the length of this arc, which is curved portion of the rope. So now what is the length of arc or curved part of the rope? Each one is 120 by 360 degrees into 2 pi r. 2 into pi into, okay, what is the radius here? R itself. Okay, 2 pi r. So this is how much? 121s are 123s are. So this is 2 by 3 pi r or not? 2 by 3 pi r. This is about the arc of one sector. How many such a sectors are existing in this figure? 3 sectors or not? So for one sector, this length of arc, that means curved portion of the rope, is this much, 2 by 3 pi r. Now what about how many such a portions are existing? 3 portions or not? So we can get the length of this plus this, making the 3 times of this value. So let us multiply with this. How much we are getting? 3 get cancelled, and this is 2 pi r. Okay, so curved portion length means this portion plus this portion plus this portion length would be how much? 2 pi r, total curved portion length. Now let us see. So here we need to get the total length of the rope. So total length of the rope means this is 2r, this is 2r, and this is 2r. That means here 2r into 3 times. Is that right or not? So these lengths are covered. Now here this covered part and this covered part, this covered part. Total just now we obtained as what? 2 pi r. So what is finally total length of the rope which is tied around? Okay, this is 2 into 3 6r plus 2 pi r. So this is a total length of the rope which is tied, which is used to tie the cylinders, cylindrical rods or pipes, okay, along the sections. Okay, this is a total length of the rope. So guys, I am telling you only one thing, that every time's results are not that easy. Means every time we can't obtain the results like doing instantly, we can't get the results. Sometimes we need to do this kind of analysis also. After doing the analysis, you will definitely get the answers. But let me tell you one more thing, that here are we using anything in a higher level other than circles and rectangles? Are we using any complex things? No, we are just using the properties of rectangles, properties of circles. Those are coming under the very basics in your 6th or 7th standard of schooling levels. That means basics are always comes from very low level only. But while doing the application, we have to make for complex things also it can be applied, and we have to make it simplified, and we need to solve like this. So tell me guys, is it an example for, okay, like easy problem in the sense to take many more steps, or to analyze its shape? Okay, there are no more mathematical steps, with very less number of steps we can solve it. But before that you need to do the more analysis for the given diagram by dividing into different portions. Then it comes to know finally what is a requirement. Here our requirement is to find out the total length of the rope which is used to tie this 3 cylindrical rods or 3 cylindrical pipes, and that would be this total length. So here this is 2r, this is 2r, and this is 2r, 3 2r's, that is 6r, and here this is pi r by 2 pi r by 3, like that 3 multiplying with 3 times, okay, that is 2 pi r, and your total length of the rope used to tie the cylindrical pipes is 6r plus 2 pi r. So this is the final result of us. So I think you would have enjoyed this concept, and don't forget to subscribe the channel so that you can get the concepts like this only and further updates. Thank you.